Hi everyone, Hadifemi Great here again, and today we are going to be upping a little bit from what we had in the last episode. So remember, in our last episode, we were able to deploy our Django projects using Zappa, and we were able to take off most of the load using Zappa. And what I mean by this is, with Zappa, we were able to just deploy everything straight up to our intended lambda function, and it works. However, there is one limitation with using that process. And if you figure it out already, is that every time we make any push to our repo, we have to go down to our actions in GitHub to actually select the operation we want to perform, which can be update or deploy. Because according to Zappa, it doesn't really understand what to do by default. So for instance, if your project is not on the server already, then you have to choose the deploy operation. However, if your project is already there and you just want to make an update, then you have to choose the update operation. So this brings us to what we are trying to actually achieve today, because one of the benefits of setting up a CI/CD and the actions is such that you can just focus on your code, and once you are done writing your code and you push to the repo, you expect the repo to just handle the rest. So what I mean in essence is that once I push my code, and it goes to the repo, it should just automatically deploy it to where I want it to go. And if it has to be an update, it should know, so as it should know if it's a deploy. So that's the process. And one way I've thought to tackle this is to introduce the Terraform. Why exactly are we using Terraform? And the simple answer to that is that Terraform is able to handle the challenge we have with Zappa. With Terraform states, it's able to know when to actually deploy your project and when to update based on the changes you've made. So this is what we'll be looking at in today's episode. We have most of our setup already, so we'll be making use of the existing code. We'll be copying most of our Zappa settings, so it's almost the same thing. However, the difference is that we won't be using Zappa to either deploy or update this time. Instead, we'll be using Terraform to handle that. So yeah, that's our plan for today's episode. And I think that should be enough of me on the sprint, which means we should actually go to the real sprint where we code things out and see what we can achieve. Alright guys, let's get started. So I have made some preparation on the sprint, as you can see. And if you're wondering where I get this code, this is exactly the code we have from the last episode, except for the fact that it's missing the GitHub workflow. Okay? And that's because we are going to be making some changes to the workflow, as well as adding a new information about our Terraform. So before we get started and do other things, one thing to note is that we have our env, which should be git ignored. And the only reason why it's not being ignored now is because this particular folder is not a repo. And to correct that, all we have to do is do git init. Alright, and with that done, as you can see, the .env file now is ignored. Cool. And before we proceed to any other thing, I think I have a quick cleanup I need to do. So if we come down to the blog views, we have this helper we are not using. We can remove that. And we can actually get rid of the brackets at the front and the back of this. Then the same thing with this queue, we are not using it. We can remove the brackets as well. Yeah, so that was a quick cleanup I thought I should do. And yeah, I think for now we are good on this part. So again, we are trying to deploy this using Terraform, and the usual flow I tend to follow for this would be to create a new folder here. So I'll come down to the root folder and create a folder called deployments. And the most important file of a Terraform project is the main.tf file. So let's create that. So one thing about Terraform is that it takes note of your names. So for instance, main.tf file is considered as the entry point to your Terraform project. So we can also have other files like the variables, the local, which Terraform seems to understand what they are used for. But in our case, we won't be using them because we are not really working with so many variables. So most of what we are working on can be directly worked on here. So as a result of that, we'll just stick with the main.tf file. Also, before we proceed to actually writing some of the Terraform configuration, we want to make some changes to the Zappa settings. So production is what we have in the last episode, and as much as that is good, I think production might just be too long. So I can shorten this to prod, which I think makes more sense. Alright, with that done, let's get back to our main.tf file and actually start defining this. So Terraform might seem a little bit hard if you've not really had an hands-on on it. And yeah, I had the same perspective when I started using Terraform. However, if you're able to get into it and write some Terraform code, you quickly realize that there is a simple pattern it follows as long as you know what you are doing. And maybe I've not said it, Terraform is actually a form of IAC, infrastructure as code. And the whole idea is programmers believe they can easily manage things when they write the code. And judging from experience, I actually think it's quite seamless when you're managing your infrastructure with code, because with a click of a button, you can easily drop everything you've created or create everything you want. So yeah, that's just about that. And let's not dwell too much about what Terraform does. And by the way, this is not going to be an intro tutorial to Terraform. I'm just trying to show us how to use Terraform to deploy our project. So with that said, just like we would have with our package.json where we define our requirements, we can also do that with Terraform by specifying Terraform here. Then we define the required providers. In my case, I'm going to be using AWS, so I'm going to specify AWS as my required provider. And I'm going to just accept the suggestion made by Copilot. I'm using Copilot, by the way. If you take note of it here, you'll see it's rolling. However, from experience, what I tend to use is just this version 3.0, like that. So it's going to find any version within the 3 point line, something like that. So the next thing I want to specify here is going to be the backend I want to use. And the reason why Terraform would kind of make our deployment seamless, such that if we've deployed for the first time, it's just going to keep updating. And if we've not deployed at all, it's going to deploy from start. Something we did not have with using Zappa directly is that it makes use of backend to store its state. So it's able to store its state to take note of where you left off. So yeah, here we're going to define that backend. And you can specify different backend, but in our case, we are going to be using S3 because everything we'll be doing will be related to AWS. So let's keep up with the AWS services. So within here, we're going to define basic information for our backend. So as you can see from the suggestion, we need a bucket, we need a key, and we need to specify the region. I'm going to accept everything. However, we don't have a bucket with this name, which we are going to define within our AWS S3. And finally, after defining the bucket, I want to specify an ACL, which is going to be bucket owner, full control, like that. So now let's define a bucket for our project. So our project is blog project TF. So let's jump down to our AWS. And by the way, this was where I downloaded this project, if you could remember, blog project, and yeah, we just downloaded the project. So coming back to S3, we are going to create a new bucket. And I'll call this blog project, blog-project -Terraform, like that. And that's all I have to do there. So yeah, we have the bucket here, and I can copy it, come back to my code, and replace it here. So the others can be kept as they are. So Terraform.tf state is going to be the file is going to create to store the states, and US-east1 is our region, which we know by now. So we are good on that note. So one disclaimer is that most times when you are trying to write Terraform code or resources for your project, you most likely don't know the resources you want. So as a result of that, you need to keep doing this and research to understand the resources you need to define and then use it. So we won't dwell too much about creating resources. I'll probably just create one of the resources and copy and paste the other based on how I've used it. And finally, I'll just go through it to tell you what it does. So this is more like requirements. But next, we need to specify the provider itself. So again, Terraform is IAC. It's not specific to any of the cloud systems or the cloud services we have, like AWS or Google Cloud or so. It can be used by any. So this can be changed to Google Cloud, this can be changed to Microsoft Azure, and so on. But in this case, we are using AWS, and the region we are working on is the US East. So the next thing we want to do is we want to create a resources for our lambda function. However, before we get there, we need a role to be able to handle that lambda function. And for that, we are going to create an IAM role. Okay? All right, so here's the resources for the lambda role we are creating, and it's an AWS IAM role resource. So this is going to create this role to manage our lambda function whenever we create it like that. And this is what it entails. So it's a new policy that we just coined up together from Terraform, and it works. So that's what that does. All right then, and here's the resource definition for our lambda function itself. So as you can see, there's a pattern here. So you define resource, followed by the resource you want to create, followed by the resource name itself. And this is not going to be the name you are going to see when the resource is created. Rather, this is the name you'll be able to use to reference this resource throughout this configuration. So for instance, I can say AWS _ lambda _ function .app .handler .function name and so on like that. So yeah, that's what this name is used for, is to reference the resources throughout the configuration. And for a lambda function, here are the attributes you need to specify. So the function name itself, which is going to be shown on your lambda function resources on AWS, the lambda handler itself. So we'll be using Zappa to package anyways, because we need to convert the old Django project to a lambda function. So Zappa can still be useful for that, contrary to allowing it to deploy like we did in the last episode. So the only thing we will be taking away from Zappa is the deployment process, but the packaging process will still be done by Zappa. And once it's done packaging, we would have access to a handler.lambda handler here. And the runtime we are going to use would be Python 3.9. So the lambda function will make provisions for Python 3.9 so that we can run our project. The timeout for a lambda function is relative. It can be more than 30 seconds. It can be, I think, 100 seconds sometimes. But because we'll be attaching this lambda function to an API gateway, a RESTful gateway, the highest timeout for a RESTful gateway resource is 30 seconds. So that's why we specified 30 seconds here. Then your memory size, if you feel your project will not use more than 128 MB, then you can specify that. So that's about that. Then the file name itself. So when we package our project, we are going to have a package.zip, and this is going to be located within our directory. So this zip file is what we are going to push to our lambda function to be actually used. So this is more like reaching out to that root directory and pulling up the zip package. So this is just the file name. And the idea about file name is no matter what, every time we package our project, package.zip would be what we get. So as a result of that, there won't be changes every time we package our project. So to track changes, which is what Terraform needs to be able to make updates, we are going to define a source code hash here, which is going to be this. And this is us encrypting or hashing the file itself. So whenever there is any changes within our project, the encryption content will change. And as a result of that, it tells Terraform to make updates to the project. Then finally, I'm specifying the role that is controlling this whole process, which is the role we defined here earlier on. Cool, right? So yeah, as you can see, we took a lot of time just going through this. So again, we won't be spending too much time on Terraform. At the end of the day, the code we are going to use for this will be available. So what I'll do instead is just copy the rest of the code, go over it, and we'll move on. All right, so we have a lot going on here. And if we scroll back, this was where we left off. So now we've provided this resource, which is the API gateway, which we are assigning or attaching to our Lambda function. But we can't attach it directly, so we have to just define the resources, define the deployment, define the methods, define the integration. Yeah, the integration is where we kind of associate the resource, the RESTful API itself, and the Lambda function itself. So that's the integration. So we integrated the roots, we integrated the proxy. Yep, yeah. So look at Terraform as you defining different resources, and you also define another resources to actually join them together. So that's what's going on here. So, and at the end of it all, we have the output. So the output is meant to just print out something that can be useful for you after a deployment. And what we want to print out after our deployment is the endpoint we can access. So this endpoint is going to be the API gateway endpoint we attach to our Lambda function. So yeah, that's all we have to do here. And like I said again, most times when you are defining your Terraform resources, you are not very certain on what resources to define. So you have to study what you are trying to deploy and make research to figure out the resources you want to use. Yeah, so that's how we get here. So now we have our Terraform deployments, which makes sense. So before we proceed to setting up our CI/CD, let's first push this to our repo, GitHub repo, and make some necessary preparation for our CI/CD. Because remember, the changes we want to make to the CI/CD this time around involves it automatically deploying as soon as we push our code. So based on that, we need to set up our access code and secret code on the repo. So let's go back to our browser. My repositories, this my repositories. I can have new. I am the owner. And I'll call this blog project TF like this. And that's all I have to do. So here we are going to add the remote. So copy this, come back to the code. So git remote add that. Can clear this out. So the next thing we want to do is to add everything we have. Git add all, git commit -m tf setup. Okay, I think that's okay. Okay, another thing to note is aside from the names here, take note of the name we've defined the prod. So if we come back to the main.tf, I actually made a reference to it somewhere. Let's look for it. Yep. So here, AWS API gateway deployments. So yeah, I'm referencing the stage name I'm using here. So the stage name is prod, so be conscious of that. So if you're wondering, how did prod come about? Yep, this is it here. So another thing I also updated is the load.env. So initially this used to be production. So yeah, again, this is prod because that's the key we are looking at here. Okay, so that's cool. That's cool. So again, let's push this to the repo, git push -u origin. Yep, so we have an issue here. So if I do git branch, we find out that we are working with master at the moment, and most times we want to convert this to main. So let's do git branch -m main, then git push origin dash u, or rather u dash origin, or rather dash u origin, then main. All right, so we've pushed that, and if we come back here, refresh, now we have our code. So we want to go into the settings, just like we did in the last episode. Come down to secrets and actions. We want to set repository secret, just like we have in the last episode. So I'll just create that and show us once I'm done. All right, guys, there we have it. We've defined the secrets. Now we can come back to the code and define our workflow. So here we are going to create a new folder, .github/workflows. Then inside our workflow, we want to have cd.yaml, like that. So again, we are going to be using most of what we have from the last episode with just a few changes. So let me get what we have from the last episode, and here it is. So there we have it. We have all this. So one first change we want to make is the on workflow dispatch. So instead, we are going to change this to on push. So whenever we make any push to the repo or the GitHub repo, then this should start. So that's what we are doing here. So again, from checkout to install dependencies to configure AWS credentials, all this still stays the same. So the only difference now is while we are setting up the requirements, we also want to package our projects. And that's quite straightforward to do. All you have to do here is do Zappa package, then the stage, which is production, or the prod in this case. Then we specify the output file. So you can use the suggestion, or we can just use the shorthand, which is -o package.zip. So this is going to create the package.zip file within the root folder, and the Terraform configuration will be able to use it there. So now, because we are not making any selection, we can change this to just deploy. And also, we won't need activating the Python environment for the next step, so we can remove this. So next, we want to cd into the deployments folder. So cd into deployments, like that. And here we want to have Terraform init. So you might be wondering, okay, we didn't make any setup for Terraform. How come we can use Terraform init directly? And that's a very correct question, because you probably won't be able to use Terraform on your machine or computer if you did not install it. So my assumption is that, because I've not investigated this myself, my assumption is that GitHub Actions have some packages defined by default. I'm pretty sure you don't need to set up Git within your GitHub Action or some other configurations like that. I think Terraform is one of those things that are available on your actual resource directly. So as a result of that, you don't need to install Terraform or initialize it anywhere, just as we've not done, to make use of it. Okay? So after we init, then we want to apply. And we want to use auto approve because we are not coming here to make any approval or perform any action. We want it to perform everything automatically. And that's all I think we need to do. And with these changes, we can go back and push this to our repo. So git add all, git commit -n, add workflow, then git push. And because this is meant to happen on push, then our pipeline should just kick off straight up. So let's come back to our GitHub to check this. So if we come back to actions, and as you can see, the pipeline already started working. So let's take a look at what it's doing. So at the moment, it's installing dependencies, and this can take a while. So I'll keep watching and let you guys know once it's done. All right, there we have it. It's done, and we have our output. So like I said, this is the output, and this is referencing to the API gateway URL generated. So if I click on this, yep, we have our projects, which looks good. So we can come back here, blog path, and check it out. So just like we have in the last episode, we have this again, which looks good. So we've explored two ways to deploy our Django project, using Zappa directly and using this. So the benefit of this now is if I come back to this, I'll come back to URLs. Maybe I just remove block tags. So let's remove block tags and save. So again, add a commit. Maybe the commit message should have changed, but let's ignore and let's push. So at the moment, if we take a look at this, we have block tags, but now we don't have to do anything. We just have to wait for the pipeline to do its thing, and yeah, it's going to figure out if it's an update or a deployment. That's the benefit of using Terraform. So let's wait for it. Again, the deployment process is done, and this time around, it's able to note that we made some changes to our project file itself, as you can see. So AWS lambda function would be updating place. As you can see, there is a changes in the source code hash, which is what we want to track. And based on this, if we refresh now, we should not have the block tags. And voila, it's gone. So there we have it, guys. We are able to establish the advantage using Terraform as over using Zappa. And actually, aside from the fact that you are able to just automatically deploy or update, you also have control over the resources you use. In the case of Zappa, Zappa assumes that for you, so it defines its resources by itself. So yeah, the ball is at the end of the day in your court. Again, the initial episode is a prerequisite to this. I don't know why I'm saying this at the end of the whole video, but if you are looking lost and wondering where do we get everything we are doing here, you probably have to take a look at the last episode, which I'm going to put in the description section. And finally, if you enjoyed the episode, if you enjoy what I'm doing here, kindly leave a thumbs up and subscribe if you've not. Until next time, take care and bye for now.